Carbon Dioxide Emissions by Randall Duke, Matthew Fish, Riley Talentire, and Luke Tilley. The combustion of coal is one of the most widely used sources of fossil fuels. Through combustion, carbon dioxide is produced, which is a greenhouse gas. A greenhouse gas traps infrared radiation in the atmosphere, which causes the phenomenon of global warming. In order to preserve the environment, one method of reducing these gases is post-combustion capture of carbon dioxide. In this presentation, we will discuss the reaction mechanism, how to transfer captured carbon dioxide, and storage methods to ensure that the gas will not reach the atmosphere.
Post-combustion capture and sequestration of carbon dioxide takes place once carbon is burned in either excess air or excess oxygen. There are three main steps to capture and sequestration. Those steps consist of capture, transport, and storage. Capture is obtaining carbon dioxide, transfer is transferring the carbon dioxide to the storage site, and storage is putting the carbon dioxide in a place where it can no longer leak into the atmosphere and cause damage. If carbon is burned in excess air, there's an extra step called scrubbing, and that happens just before capture. Scrubbing is a process which purifies the carbon dioxide. With this overall knowledge of capture and sequestration, let's go take a look at how the reaction occurs. After the reaction has occurred, there's a chance, as stated before, that our byproduct may not be pure carbon dioxide. If the reaction has occurred in pure oxygen, then the product will be pure carbon dioxide. But if the reaction occurred in air, in order to obtain the carbon dioxide, it will need to be scrubbed or purified. As previously stated, scrubbing is a way of purifying the gas. Let's check out how the gas is captured and scrubbed.
Is that pure CO2 right there? I gotta go capture them.
After the capture of the gas, it is transferred to a storage site. This is usually done via a pipeline because it is the most cost-effective method of transfer. Let's go check out the transfer. Storage takes place once the transport is complete. There are three types of storage, and they are ocean, geological, and mineral. Ocean storage is when you store the excess carbon dioxide in the ocean, but because of EPA regulations has become illegal because of the harmful effects on the ocean ecosystem. Geological storage is done by injecting the carbon dioxide in a supercritical state into a rock formation. Supercritical is a state where the material is at a higher pressure and higher temperature than the critical point of that material. Mineral storage is done by reacting the carbon dioxide with metal oxides to form stable metal carbonates. Let's take a look at this reaction for mineral storage.
Now that we have looked at how carbon dioxide is formed, let's explore how it affects our atmosphere. The greenhouse effect describes a process in which infrared radiation is trapped in the Earth's atmosphere, keeping the climate warm enough for plants and animals to survive. It begins with sunlight entering through the Earth's atmosphere, where most of it is absorbed by land and water, and the rest is reflected back into outer space. The energy absorbed heats up the Earth's surface and is eventually released as infrared radiation. Ideally, most of the radiation is released past the Earth's atmosphere into outer space, and greenhouse gases reflect a very small portion of the radiation back to Earth in order to ensure a climate in which life can prosper. This process was simple enough, but became much more complicated due to the Industrial Revolution. Daily tasks such as using electricity or driving a car to industrial and chemical processes within factories create a buildup of carbon dioxide in the ozone layer. Greenhouse gases can be compared to a blanket that keeps the Earth at a perfect temperature. However, the more greenhouse gases, the thicker the blanket, the hotter the Earth. Let's take a look.
The greenhouse effect acts as a blanket to the Earth, causing it to get too hot, which causes global warming.
So hot.
Because there are more greenhouse gases in the atmosphere, more of the infrared radiation is reflected back towards the Earth, causing it to heat up faster than life can adapt. This has become a major problem as this climate shift has the ability to affect weather patterns in snow and rain, as well as the polar ice caps melting. All of these side effects of overproduction of carbon dioxide are rapidly affecting the Earth and therefore life on Earth. While this greenhouse effect is not bad in itself, as it's necessary to keep the Earth warm, too much of the effect is beginning to cause global warming. The Earth's temperature is rising exponentially, and the severity of the environmental effects are drastically increasing. Global warming is responsible for extreme weather patterns, and it threatens our health, communities, economy, and national security. In only 10 years, carbon dioxide in the atmosphere has gone up by 101.58 parts per million, an astronomical amount. This has led to the overall global temperature to increase by 1.4 degrees Fahrenheit, and the amount of Arctic sea ice to decline at a rate of 13.3% per decade, relative to the 1981 to 2010 average. This temperature increase is not only causing the sea ice to melt, but is even having a drastic effect on Greenland. The country has suffered a significant mass loss, and it has been estimated that Greenland has been losing 287 billion metric tons per year since 2002. It must also be considered that this ice is not simply disappearing into thin air. The oceans are expanding, which places all land masses at risk of becoming smaller. The carbon dioxide that is already in our atmosphere will remain there for the next 100 to 200 years, and scientists predict that this will cause a rise in global temperature from 2.5 to 10 degrees Fahrenheit, a significant amount considering the overall climate change that is already taking place due to the global temperature being raised by only 1.4 degrees Fahrenheit. This trend is only predicted to increase in intensity. An extreme increase in temperature, a drastic sea level rise of 1 to 4 feet, an overwhelming increase in the power of hurricanes, precipitation patterns, heat waves, droughts, and a potentially ice-free Arctic Ocean are the possible outcomes of this trend. We are already seeing droughts in areas such as California. It is extremely important to note that this climate change is so drastic that it cannot be attributed to natural variation in Earth's orbit and is in fact very likely human-induced. This rate is not sustainable, as species of plants and animals cannot adapt rapidly enough to compensate for the incredible speed of the climate change.
Though there are many environmental benefits for companies to capture and store all carbon dioxide, there are fairly hefty economical downfalls that cause them to release carbon dioxide to the atmosphere. Releasing carbon dioxide is completely free, while storing it is very expensive. There are regulations, though, to prohibit such acts of releasing all carbon dioxide, and the EPA limits how much can be released. The main downfall of capture and sequestration of carbon dioxide is the energy penalty. Some processes can lower the output of a power plant by up to 25%. This penalty can nearly double the cost of electricity for the average home, so everyone is losing.
The use of coal in today's world is significantly less than the use in the past, but it is still a significant problem. This trend of carbon dioxide emissions shows no sign of slowing down, And for that to happen, carbon dioxide capture needs to be installed in most, if not all, power plants. If this doesn't happen, our atmosphere will crumble alongside all of the plant and wildlife. Finally, although it can cost a company up to a fourth of its production, this is significantly less than the cost of our world. That is why carbon dioxide capture needs to be utilized by all power plants.